morning, everybody, for the information day on the Pathfinder Challenge Clean and Efficient Cooling. My name is Annemarie Sasse. I'm the head of unit of the Program Manager's Office in the European Innovation Council. And I'm here today with Marco Antonio Pantoleo, who is the Program Manager for Energy Systems and Green Technologies. And he will be the one explaining you everything about the Pathfinder Challenge, and I will give a short introduction to the European Innovation Council. If we go to the next slide. Yeah, so the agenda of today is that, as I said, I will just explain very briefly the rationale of the EIC funding programs. Then Marco will continue with explaining the background on why he selected this challenge on clean cooling. He will also say exactly what he would expect of you when you write a proposal, give some examples of what he had in mind when writing the proposal, and then he will explain how we select a portfolio of projects, because that is something which is very specific for Pathfinder challenges, and that's something new that you would need to understand very carefully. He will also tell you what the proactive portfolio management for this portfolio of clean and efficient cooling will be. That would be after your project has been selected and you have received a grant of us. Then we will have time for questions and answers, so you can ask any question that you have in the Slido, and we will answer all the questions. And after that, we will have 11 organizations who want to give a pitch to present what they would have to offer for this call in order for matchmaking for future proposals. So next slide, please. This is the link of the Slido. Please join there. Use the event code challenges, and there you can raise all the questions that you have. So today is your opportunity to ask questions. Later on, if you would have, when you prepare your proposal, you would have questions, then the idea is that you contact your national contact point, who is probably also listening to this presentation, and your national contact point will be able to answer your question. So only today is your opportunity to directly talk with Marco about the challenge. This event is recorded, and we will make all the recording and the slides of the event available on the same event page. So if we go to the next slide. So the European Innovation Council, it's part of Horizon Europe, and in Horizon Europe, the research is structured in 3 pillars. The first pillar is on excellent science, and there, for instance, you find the European Research Council, the ERC, which most of you are aware of. We have pillar 2, which is dedicated to collaborative research, addressing the global challenges that we are facing in Europe. And then pillar 2 is on itself also organized in different clusters, which you can see on the slide. And then we have pillar 3, which is called Innovative Europe, and the European Innovation Council is part of pillar 3. And that is also to distinguish it from the other pillars, that the focus is really on innovation, bringing breakthrough technologies to the market. Marco? And in order to do that, to make sure that all the good research that Europe is doing, that it will reach the market, we have 3 different instruments in the European Innovation Council. The first one is Pathfinder, and today the info day will be about Pathfinder. This is to support early ideas that potentially have a groundbreaking nature and that can solve an important problem. So Pathfinder is early research, just like ERC, but there should be a clear purpose, and the purpose should be that if all this works, this idea, this can bring new services and products to the market in areas where Europe needs this. And so it's low technology readiness level research. It can range from 1 to 4. And we expect that at the beginning of a grant, the TRL level is maybe 1 to 2. But at the end of the project, it would have risen to 3 or 4. It is for consortia. And in some cases, it can also be single entities. So early stage research on breakthrough technologies, and you would receive a grant up to 3 to 4 million euro. So this is with the Pathfinder, you would develop a proof of concept to see whether your idea in principle works. And it could be that your research will advance so quickly that you are immediately ready to bring it to the market and to go to the accelerator instrument, which is the third instrument. But in many cases, it's necessary that you would need an additional grant to further mature your technology and also to look at aspects related to creating a business and being ready for the market. And in those cases, you can apply for a transition grant. And in transition, the technology readiness level at the beginning is 4, and at the end, you should have brought it to TRL level 6. Also, transition is for consortia and single entities, and you would receive a grant up to 2.5 million euro. And then the largest instrument of the European Innovation Council, it's the accelerator. An accelerator is for individual SMEs, for startups, but also scale-ups who are bringing their product or service to the market. And this here you would get blended finance, so there can be a grant part up to 2.5 million euro, which would be for further developments which are necessary, and then an equity investment up to 15 million euro, or in some cases even above, which would be for scaling up your product in the market. So these are the 3 instruments. If we go to the next slide. So we range really from technology readiness level 1 to 9 in accelerator. So you can see that in this slide you see the 3 instruments again, and you see that the technology readiness level goes up from Pathfinder to transition to accelerator, but not only the technology readiness level, also the commercial readiness level, and that's very important. So in the beginning, when you are still in Pathfinder, you're doing really research, deep tech research, and you are addressing questions which starts with a what. What can my technology do for me? How can I get my technology to work in an optimal manner? And you're focusing a lot on the technology to really develop the core of that. Whereas when you are in accelerator, you are more looking at commercial issues. And the main question that you are asking yourself is why? Why would customers be interested in my product? What is the unique selling proposition that I have, and how do I place that in the market? And so the perspective moves also towards more commercial issues which need to be addressed to be a successful entrepreneur. If we go to the next slide. And you will be supported on your entrepreneurial journey because the EIC does not only give grants or equity investments, but it also gives support. And that is what we call proactive management, which is also something new for the EIC. And we don't have it, for instance, in the Pillar 2 of Horizon Europe. So there are 3 elements of the proactive management. First are the business acceleration services. These are available for all beneficiaries of the EIC. And what we do in the context of these business acceleration services is, for instance, to give you access to entrepreneurs, access to mentors, to ecosystems. And an example is, for instance, that we organize days with corporates, large corporates who are interested in meeting the SMEs that we are supporting and who would like to see the innovations that they are bringing. So we have then corporate days where the startups are invited to the headquarters of this corporate. There will be pitching, there will be matchmaking, and quite often this leads to a longer term relationship between companies where the corporate is interested in and the SMEs. We also organize trade fairs where also SMEs who are, usually these are the accelerator projects, who are ready to reach the market, which will come to this trade show. And we organize a common booth. So there are many activities for the business acceleration services, but we also have program managers. And today you will meet Marco Pantaleo, who's the program manager for clean tech, let's say. And we have 10 program managers, and they are all in different areas. The program managers have a very special profile. They are hired by the European Commission for 4 years. They usually have a PhD in research, so they are very specialized in a certain domain, but they've also brought some research to the market. So they have either created companies or they have worked in tech transfer services. So they also know what it is to bring research to the market. They have many contacts with investors, for instance, which are relevant for the domain they are proposing. And they do two things. They, first of all, create the vision that is behind a certain challenge. And then once the projects are selected, they proactively manage these projects and do common activities with them. So if we go to the next slide. So this now is a slide which gives an overview of the whole work program of the EIC in 2023. So you can see our total budget is 1.6 billion euro. In the EIC, each of the three instruments, they have an open part where you can submit any proposal as long as it has the TRL characteristics that I explained. So for Pathfinder, about half of the budget is open and the other half is dedicated to challenges. The same for transition and also the same for accelerator. And if we look to the challenges, you will see that if you follow the red line of Pathfinder, you will see the 5 challenges that are open for Pathfinder. And the first one is clean and efficient cooling. And today the info day will be about clean and efficient cooling, but we have organized similar info days for all the other challenges. So if you are interested in another challenge, for instance, the accelerator challenge on energy storage technologies, which is also driven by Marco, you can look to the recording of that one. It is available to you to fully understand what is behind this topic in the work program. So now my final slide, that's an overview of the deadlines that we have. So the Pathfinder challenge for the deadlines for Pathfinder, for the open part, it has just passed, the 7th of March. But for the challenges, there is still enough time. The deadline will be the 18th of October 2023. You can also see the other deadlines if you are interested in transition or accelerator. So with this, I want to hand over to Marco to explain you everything about the clean cooling technologies Pathfinder challenge.
Thank you very much, Anne-Marie, for this comprehensive overview of EIC, and thanks to everybody for attending this info session. I will describe a bit more what we expect to capture with this challenge, starting from to reinforce what Anne-Marie said about the purpose, the aim, the ambition of EIC to nurture innovation across the whole journey from low TRL and fundamental science to business development and startups. So in transition, we are at the very early stage in laboratory research, but with the perspective, at least the initial ambitions, to have a clear application and have a possibility to scale up this proof of concept with future funding opportunities in EIC or elsewhere, transition and accelerator mainly in EIC. So what is one typical characteristic that differentiates Pathfinder from ERC funding is this focus since the beginning on potential innovation and potential development of these fundamental science into market business opportunities. And this is an ingredient that we would like to see in our proposal that we receive. Also with a fair comparison, for instance, with state-of-art solution and technologies that are competitors of what you propose. So the ambition is to investigate and assess something that could really be, if successful, a breakthrough and could produce a transformational research that can be implemented in the future in the real world. What is the starting point? Of course, it is the key prior research and energy policy priorities of Europe or any country that are sustainability and green energy, but also circular economy here. So we pay attention on renewables, on waste heat, for instance, and this is also integrated into the challenge, but also on the concept of reuse and recycle and the possibility to use non-critical material and substitute materials also for cooling technologies with more sustainable ones, and assess also the aspect of energy saving and efficiency, and we will see. But of course, there is the dimension of security of supply and open strategic autonomy, maybe a bit less relevant here in clean cooling, but is incorporated in the possibility to integrate renewables and diversify the energy supply, and of course competitive and cost reduction. Cost of cooling are very relevant in particular in several market applications in some food industrial sector, so it's particularly important to have high efficiency solution that can increase the competitiveness of the industrial sector. This challenge is particularly well aligned also with the Green Deal Industrial Plan, and just released a Net Zero Industry Act that complements the Critical Raw Material Acts and the electricity market design, just under discussion in these days at Commission level. And also the key recognized research innovation needs of also capturing this challenge are related to system integration, circularity and critical raw materials, opportunity to decarbonize the cooling sector. I go on quickly here to show that cooling is very transversal and cooling technologies are strategic in several sectors, from hydrogen, so storage and transport of light molecules for energy as energy carriers, energy storage, but also buildings energy demand, and so on. But so far we recognize that a limited effort has been put in fundamental and transformational research for specific for cleaning cooling technology. So this we would like also to bridge this gap and to fulfill these research needs. What is the scope of the call? So we are targeting a broad range of applications at different temperature level, from very low cryogenic level to refrigeration for buildings. The purpose is to address areas such as data centers, electronics, barriers, electric vehicles, materials and thermal management in these applications, but also built environment, increasing built health and comfort, or also interoperable urban energy systems. The dimension of food production and storage, for instance, including, for instance, vertical farming, all the needs for refrigeration and cooling in this fast increasing sector, and refrigerator transport, the production of liquefied natural gas or liquid hydrogen to facilitate the transport and of these energy carriers, or application in hard-to-abate industrial sectors. So the needs for research and innovation are related to areas such as computational modeling, optimization, and validation for specific components into the world system, or heat transfer processes, new working fluids and refrigerants, more sustainable. We target unconventional refrigeration principles to the extent they can have the ambition to obtain efficiencies that are higher than current solutions, and with, as we will see next slide, with significant, not negligible temperature difference, temperature gradients achieved, so minimum 5 degrees, not 0.1 Kelvin or so, very, very, very limited. So we really would like to see something that could have an impact. So unconventional refrigeration principles regarding magnetocaloric, electrocaloric, elastomeric, and so on, also photonic cooling, and technologies for net zero cooling for industrial residential sector, combining the use of solar, geothermal, hybrid pumped heat or heat transformer. Here there is an important aspect to increase the COP of heat pumps with high temperature lifts. So when we want to achieve high temperature gradients that are needed, in particular if you want to substitute old boilers in buildings that produce heat at 60, 70 degrees. Now, if we don't want to limit the heat pumps to 30, 40 degrees, but we want to increase the temperature level, then we want to assess solutions, maybe hybrid heat pumps that can achieve high COP at high temperature gradients. And so, in a nutshell, we aim to investigate new devices, processes, components, and or materials for cooling to reduce investment and operational costs, to increase efficiency, operational reliability, and interoperability, avoid use of critical raw material that harms refrigerants, and pursue a circular by design approach. Here also there is the component of diagnostics and management of cooling demand, increasing the efficiency in operation of specific technologies. So with systems that enable sort of soft fault detection to assess not optimal operation that will reduce the efficiency of these technologies. And as I said before, the proposal should refer to the expected COP, the expected COP of the proof of concept of the solution investigated to the maximum theoretical COP that can be achieved with the inverse Carnot cycle. Of course, if it is relevant for the application proposed, because we can also address both active and passive cooling, and we aim to have solutions that can be competitive with the state of art of at the proposed operating range, and the solution that should aim to achieve single stage temperature gradients higher than 5 degrees. So to have something that could really have an impact, and not only be relevant for a niche market application. Relevant for, yes, I can go quick here and shift. Some examples of what we can be captured here. For instance, innovations in heat transfer heat exchangers from materials and topology of heat exchangers. There are research on additive manufacturers of heat exchangers, or processes for the extrusion or solid state cooling innovative coolants for electronics and batteries, and other innovation regarding to the improvement of evaporation or condensation processes, and to minimize space needs at the same times. At components level, so also we can you can investigate areas such as wet compression and combined pump and compressors for heat pumps, use of phase change material substrates for electronics and batteries, or areas such as electrodynamic accelerator of dielectric media that are implemented in data centers in electronics. The use of light as refrigerant is a niche area that could be promising with the application in thermophotonic coolers or using electroluminescent cooling processes. Radiative cooling is another example that can be, for instance, integrated in building with specific metamaterials or integrated in solar for solar radiative cooling solutions. Some other examples could be related to refrigerated transport, and so, for instance, using trucks fed by liquid air, liquid nitrogen, or cryogenic expansion engines. The dimension of waste heat recovery combined with cooling is also important. I mentioned before heat transformers and solution that can recover the heat rejected in cooling processes is also in scope, and for instance innovative compressors that can use external voltage to pump hydrogen and so on. These are some examples, and other examples here are taken also from some new technologies also explored and funded by EIC among the other funding institution. For instance, wet compressions with integrated compressor that can operate with wet gases and reduce the number of components into heat pumps. It is clear that the combination of storage, in particular thermal storage and heat pumps, could increase the overall efficiency of the process, and this could be also captured together with the use of cooling to increase the flexibility of energy systems and as electricity or energy storage medium. Also, application such as thermoacoustic heat pumps that could offer higher COP at higher temperature lifts could be promising and are quite let's say novel, even if the solution technology is already well known, but not applied to specific to application in for buildings at large scale level. I would like, yes, to add something on the process for submission. So we have an evaluation that is composed by two steps. The step one is related to the individual project. So a number of remote evaluators review the proposal. Then we have cross readers that check the consistency and of the evaluation of each remote experts to see if there are discrepancies, and everything is done on the single specific project, assessing excellence, impact, and implementation with specific weights, as we will see soon after. And only after having evaluated the single proposal and assigned a final score in step one to the single proposal, we go to the step two, which is the ambition to build a group of projects retained, a portfolio that can collaborate, address diversity in the sense that we want to capture possibility for different technologies and not support only one technological area. So we want the diversity, but also we want to guarantee that this project can have something in common, can cooperate, can build synergies, and can achieve more ambitious results together. So we want to pursue excellence in the individual project in step 1, but in step 2, on the basis of all green and eligible proposals that have a score higher than minimum threshold, we want to compose the best portfolio, the excellent portfolio, with a proper combination of projects. And that's the way the different criteria are considered. So it's a Pathfinder. So we pay a lot of attention of excellence that has weight 60% versus impact and implementation that has respectively a weight of 20% each, with a threshold that is 4/5 for excellence and 3.5/5 for impact and implementation. You can find the challenge guide that describes the portfolio consideration that I will introduce quickly now, and all the details, some more elements of the scope of the call online, and together with the call description, which is in the work program. So portfolio consideration are based basically on the exercise to map the proposal in categories, which guarantees to address diversity. These categories will be composed here according to what written in the challenge guide in 3 broad areas of cooling generation, cooling storage and transport, and cooling management and end uses of cooling, because we would like to capture these 3 dimensions. And in this dimension, we try to explore potential synergies and collaboration that could be at materials level, final end user applications, fundamental process explored, and so on. So these portfolio considerations are introduced only at the end of step 1 during the panel evaluation, where a number of remote evaluators are invited to join this panel week, when we again together with the panelists, the experts, assess the individual projects before, and then in the last days of the evaluation, we look at all the proposals together to see how to compose this portfolio. And here you see again some examples of consideration and elements for the portfolio building that will be implemented on the basis of what we receive as proposals. So categories are the generation, the storage or transport, and cold management. Complementaries that can be captured are, for instance, application range, temperature level, processes and technologies proposed, and the shared components could be at the level of component, device integration, material selected, and possibility to integrate the solution into all cold chains. And these are examples, and the specific portfolio consideration can be then introduced and defined only when we see all the pieces of the puzzle, and we can implement the vision of the challenge to connect the dots, the different proposals, and to see what we can propose as potential portfolio activities. In fact, the applicants, you are invited to include in your project a dedicated work package for portfolio activities with at least 10 person months that, of course, will be then better detailed when we have clear view of which are these portfolio activities. This depends on the interaction complementarities with other projects. But for sure, typical activities that we want to pursue in our portfolios are comparing solution with similar metrics and understanding where each solution, technology, proof of concept could best fit with the market need. So having a sort of comparison with the other solution proposed by the other project in the portfolio and with benchmark. The ambition is also to try to address current regulatory issues, legislative issues that could be a bottleneck for some innovation. This can be done with proper tools from innovation deals and sandbox and of course the possibility to build an innovation ecosystem in clean cooling technologies around this portfolio is a huge added value, and we have exactly this idea in mind to put in contact also the project retained with already funded project at Pathfinder or accelerator level in the fields of cooling. We have already a significant number of projects in this area to facilitate synergies within EIC, but also to explore synergies with other funding programs in Pillar 2. And if we see some breakthrough research developed also by ERC funding, we can facilitate these interactions. These are all activities that could reinforce the capability of your idea to scale up and become an entrepreneur opportunity. We also would like to facilitate the access to open innovation test beds and other research infrastructures, address when relevant standardization activities with the relevant DGs, in this case probably DG Energy and the DG RTD and the groups of colleagues in the Commission that are working on clean cooling and heating. We can have common communication and dissemination plans and also exploitation of the explored solution at different market levels. All these are possible common activities, common portfolio activities. This info session is recorded, so it will be possible to have access to this offline, and you can contact your national contact point for further detail, or you can reach me also by LinkedIn, for instance. And of course, for other funding opportunities, I invite you to have a look at the work program 23 of EIC. I now will give the floor to questions and answers, and then we will listen some pitch for matchmaking. And these 11 colleagues are candidate to present their ideas for matchmaking purposes. I want to remark that we have no check and know about these ideas. I'm sure they are very good excellence, but there is no guarantee that they are fully in scope or with any kind of priority in evaluation or so on. It's just the purpose to facilitate matchmaking among the potential applicants. I would like to, yes, leave the floor to some questions if there are. Otherwise, I can add something more.
Thank you, Marco. Yes, there are some questions, so we can go over the questions now. So the first question: can we submit an application at EIC Accelerator Open and another one at EIC Accelerator Challenge? Thank you.
Well, we are in Pathfinder now, not
Yeah.
in Accelerator, first of all. Then, well, to the extent it is not the same one, I think you can present two different applications. If you present exactly the same in the open and the challenge, doesn't make too much sense. I would say no, choose for your single application where you want to apply in the open on the challenge.
Yeah, and I want to add to that, even though this is possible, if you are an SME or a startup, probably you're not doing two different businesses. Let's say, yeah. So you also need to question yourself, why do you need to have two different proposals? So if it is the same one that you are proposing, then it's better to choose whether you want to have it. If it fits the scope of the challenge, it's better to submit it to the challenge. If it doesn't fit the scope of the challenge, then you submit it to open. But if you are a startup, it's unlikely that you have the capacity to start two businesses at the same time. Okay.
Limit
Then,
to number of proposal SMI can take part in, I would say no. There is no such limit. Anne-Marie, can you?
no, there's no limit, but again, it's your capacity. Can we lead more than one? So you are an SME, you want to achieve a certain research goal. And that, of course, should be supported by the proposal that you submit. And you can submit another one. There's no rule that it's not possible. But please only submit proposals that make sense for your business and not ones there. You shouldn't try to get proposals for the purpose of having a grant. If it's not in line with your business, then it doesn't make sense.
Yeah,
But
focus on, yeah, focus
focus.
can be linked to excellence. So we encourage focus to
Yeah,
get excellence.
but there's no limit.
Yeah, and then if a research institute is currently involved in a recently funded EIC Pathfinder project, is it allowed? Yes, to participate in another Pathfinder application? Of course, yes, there is no such a limit.
And research institutes are usually also quite large. They have different research groups. So it's also logical that they are interested in different projects in Pathfinder as a whole. Yeah.
And also inside the consortium, is it okay to have more than one partner per country? Yes, it is possible. Of course, we encourage, yes, geographical parity. There are some rules about minimum 3 member states per in the proposal, but you can have more than one partner per country.
Yes, indeed.
How important is, sorry, Anna, you want to
No,
add something?
no, go ahead.
Okay.
Go ahead.
How important is it that Pathfinder says to include SME? Is it a plus? What about bigger companies involved in the project? Well, I can say there are no specific rules. So you are free to have SMIs or bigger companies. There are pros and cons in each case. To the extent you justify the role and of each partner, and it is clear the contribution of each partner, and you can defend the composition of our consortium, I think everything is good, is fine. Anne-Marie?
Indeed, everybody should have a clear role, and the topic of the research you want to do, there it should also be logical that it's this consortium because they are able to carry out the work. And if for that you need an SME or you need a bigger company, all that is fine. Of course, the advantage if you include an SME is also if then really this SME wants to exploit this potential product or service that you are developing, of course, then it's good that the SME is already involved. But if it's an SME who does totally different things, then it doesn't make sense at all. So you always have to think about the purpose of your research and compose your consortium in line with that so that you really have the best actors to do the work that they need to do.
Yes, and then is there any budget limit for each partner of a consortium? Well, there is not specific limit, but of course we need to have a proper balance across the partner of the consortium.
Yes, every partner should have a clear role, and with that role, a certain budget is associated. So that is what is important. It's always the content of the proposal that is important, and then other issues like how much budget does every partner need, they follow from that. The only limit that we have is the overall budget, which we propose is around 3 to 4 million euro. But even that you can deviate a bit if you can justify that, because this is what you need for your research.
Yeah, exactly. And if working on unconventional refrigeration, should a given potential application be targeted specifically? Yes, this is encouraged. It is a challenge, a Pathfinder challenge. It is a low TRL, of course, fundamental science, but it would be useful to target already a potential application to tailor your proof of concept for some specific implementation. This would be encouraged to yes, you can also propose something that is let's say a sort of a market agnostic or can be applied in several sectors. Correct, you can discuss this, but would be good to define a technical specification of the product that you are developing for a specific end user needs. And then in page 14, do proposal need to address all four research innovation needs? No, you can target only one of them, more in combination. There are no restrictions to have all of four of them, not at all.
No, we encourage you really to be focused.
Yeah.
And not try to address everything. It's with the portfolio composition that we will in the end cover all of the whole portfolio and all of the challenges and innovation needs.
Exactly. Is the high risk, high gain approach compared to what asked in the previous FET projects? Well, Anne-Marie, you can probably reply better than me here.
Yes. Certainly, Pathfinder is a successor of the FET program, so it compares to many ways. But now FET is part of the whole EIC, and we also have transition and accelerator. So there's even more interest on potential innovations and thinking about how your research can be used after you've done the research.
And then this is interesting. The project should be high risk, high gain. How much is the high risk essential in comparison with the feasibility of the proposed new technology? It is embedded in the concept of low TRL and proof of concept. I would say we in Pathfinder, we prioritize the high risk versus the feasibility, because we want to give an opportunity to crazy new out of the box ideas that, if successful, can be transformational. So we cannot be conservative and say, okay, yes, but it's too risky. To the extent you demonstrate proof that you know what you are doing and you have evidence that this could work, of course it has to be risky. It could be not feasible, but we encourage you to to give it a try. And this is exactly the instrument that can give these opportunities to crazy ideas.
Yeah, indeed.
Thank you for hosting the session. I have a couple of questions on the consortium rule. Are UK partners allowed to participate in the consortium? To what I know, yes, because then UK partner will be funded by UK research centers. This is the last news that I got, but this changes very, very quickly because of the agreement Europe-UK. I encourage to contact the national contact points, of course, for this. Will the portfolio try to balance classical compressor technology improvement with more risky approach like photonic and solid state? You can also do this. You can also, not necessarily, but we encourage also to explore advanced compression techniques that can mix different solutions. Why not? This will be also in scope. It's not mandatory, but is absolutely an option. Is there an expected split between capital expenditure and labor components? Well, it's a research project, so you can, of course, develop test beds, so infrastructure for testing. This is should be in the eligible cost and working so labor costs, but no, we don't have an expected split and a share between cost of items of products and man hours works. This is up to you, to the extent you are consistent and
Indeed, here again, it's your research that
yeah.
determines whether this is needed or not, and also what you already have available or what you need to invest in further. So this is really your decision how to do this.
Yeah. And again, we will collaborate with the Swiss-based research institution. How should we integrate them in the consortium? Swiss government provides financial guarantee. Yes, exactly. You can include them in the consortium. The budget will be covered for their participation by the Swiss government. So, but I think it's absolutely possible. And yes.
Indeed.
Is there an accessible list of EC funded projects dealing with cooling? Yes, we have a portfolio of projects funded in Accelerator and in Pathfinder in cooling technologies, and maybe we can put on the website a list of this project in the page on clean cooling technologies. This is public data. It's funded ongoing projects, so we can put easily the list. I have it. Yes.
The EIC also has a repository of all the projects that we are funding. It's on the EIC website. And I don't know, I didn't try it out, but if you in there would type in cooling, maybe you find something. If I have time, I will try it, but it could be that that gives you the answer.
Could you expand on regulatory side, in particular synthetic HFO refrigerant have major eco problems but are allowed under FG gas? Well, we want to explore also possibility to use such more sustainable refrigerants, and it depends on the project that we retain. And in this case, maybe if we have projects in this field that are successful and retained, we may want to, together with this project, apply for regulatory framework amendments to recognize the more sustainable value of this refrigerant versus our alternative refrigerants. This is something that is already ongoing, and there are several discussions, but we will try to put this project in a common table with people in DGs that are in charge of these specific aspects. This challenge is open also to existing Pathfinder consortia that could find a potential to exploit their original technology also in this topic. Well, that is more for transition, I would say, if you want to go, because to apply again for a Pathfinder, if you demonstrate that you really want to do a different research that still needs, again, funding at low TRL, that is comprehensible. But what we expect from an already funded Pathfinder project is to go on and to go versus transitions rather than staying again in Pathfinder. But theoretically, is possible. No premiality for this, of course, but you can.
Yeah, but it's more logical you go to transition. That's exactly the purpose of transition.
Yeah. Do we have to include proprietary information in the application, and will it be protected? Well, you know how to divulgate your data. If there are confidential sensitivity data in the application, you can just mention that that there are patents in that. But please consider that all the review, the evaluation is protected by confidentiality agreement, and all the evaluators cannot divulgate at all any information, any data that are reported in the proposal. So from this point of view, you are protected, but there are different ways to show. We need to understand the real contents and the scientific value of your proposal. If you say, okay, we cannot divulgate this, but please recognize the excellence, this can be difficult. So let us understand the value, the scientific value of your proposal, and be sure that everything will be protected during the evaluation process. Is energy recovery from cold within the scope? Yes. Somehow, yes, it's also linked. Usually we can recover waste heat from cooling application, but theoretically also this. I mean, if you are referring to waste heat discharged from cooling from at the evaporators, this is absolutely in scope. I already explored the opposite, if I well understand. So cooling recovery from heating, don't know, but yes, or cascade effects and combination of technologies are in scope, to the extent you address cooling, of course. Will liquid desiccant evaporative cooling technology be of interest for this? It is in scope, yes. It's one option that can be considered, sure. What are the timelines for proposal evaluation, and will there be interviews? Well, timeline, there won't be interview. We are considering maybe to add for, but it's not at all for this work program. So the timelines for proposal evaluation will be in between November and February. Remote evaluation before, and then you are expected to have a feedback in 5 months. We are already part of the EIC Accelerator program. Can we anyhow apply with a new project for the EIC Pathfinder program? You can apply, you are eligible, of course. Please consider that Pathfinder is completely different from Accelerator. You know well, and I hope you understood something more from Anne-Marie presentation about the different nature of our funding instruments, but of course you can. Can you try to elaborate on what excellence means in this context? How does it relate to incremental but necessary elements to early stage innovation? Well, it's we are not saying the ambition is to have non-incremental research, but we recognize it's a bit difficult because every kind of research idea is already, even at preliminary level, explored. The consideration regarding excellence are similar to the ones for other Pathfinder Open or ERC or even Pillar 2 projects. So it's the scientific merit of the proposal of the idea, and of course should not be a solution that is already well investigated, explored, with no contents of innovation at early stage level.
It should really advance the state of the art.
Yeah.
In certain ways.
Exactly.
Yeah.
Yes. Can proposal involve partner from a single EU member state only?
Yes, in some cases, yes, in the challenges. So you can look at the specific eligibility criteria, but it is possible that even a single participant submits a proposal. But if you have a consortium, then the rules are different, and then maybe you need to be of different member states.
Yeah. Must the possible applicants be present today to introduce the possible proposal, or are further groups that can decide later to submit a proposal? Absolutely, yes, you can submit any proposal. This is just a matchmaking opportunity. No needs to be present here to submit an application. Please, you are free to propose any kind of idea later on, disregarding these pitches of today that have only matchmaking purposes. What is the right balance between the number of companies and that of academic partners? No specific balance. It's again up to you. We want to have a good composition, but Even there are not restrictions that you must have companies and academic partners. You can be all academic partners or even all companies, but a good balance sometimes is appreciated, but there are no rules again.
Again, it depends on your project. The content of your project determines which partners you need for it. Marco, I have
Yeah.
a question. I see that we never reach the end of the questions because there are more and more.
Agree.
But we also had the people pitching. So what I propose is that now we go to the pitches, and then we resume with the questions after the pitches have happened. If
Absolutely.
that's okay with everybody, and then you can even raise a question to one of the participants that pitched their presentation.
Yes, great. Okay, so the first one should be, let me see.
The first one is Leon.
Yeah, I'm here.
Yeah.
So your 3 minutes starts now.
Okay, well, thank you very much. My name is Leon Stille. Together with my sort of co-founder Hielke Hekman, we are introducing today Solar Ice, the sustainable off-grid cooling solution. Please go to the next slide. I think that Antonio did a very good job to already say that why is this important, so I won't stay here for long. But obviously, cooling, and especially we are targeting the air conditioning market as a sort of replacement technology, is very important. We are still experiencing, of course, global warming. Even though we will make all the targets, we will still have a slightly warmer planet than we had 100 years ago. So we need to adapt to that, and you see that people are doing that by buying a lot of air conditioning units, straining the grid, making sure, and also having a lot of cost and energy that is being used for cooling. We want to make sure that happens in a sustainable way. So our technology is hopefully a solution for that. Can you go to the next slide? So basically what we have is a drop-in solution, at least what we are trying to develop is a drop-in solution for an air conditioning unit. The idea is based on using salts. So we're using different types of salt mixture, that when you are combining that with water, so you dilute it in water, it will create cold energy, it will create ice, more or less. That's why we call it solar ice. So the idea is that there is three vessels that are insulated vessels that where the salt is inside. You will make it contact with water. It will create cold energy. The cold energy will be transported away by just using water. Once that the cold energy has been expended and transferred to a fan in your house or in the factory or whatever you want to cool, the salt mixture gets regenerated by evaporating the water, and that is being done by just a standard solar thermal collector. So basically everything is just standard technology you put together. And our initial calculations and models basically found out, because we did this together with TNO, which is a technology that has been developed partly by TNO from the Netherlands, which is a large research institute, that you can get cooling for approximately the same investment price as you have cooling now. So the same price per kilowatt of cooling as a good air conditioning unit, but the operating costs are very low. There's almost no electricity involved, only just transporting some water around and a fan. For the rest, you're using the thermal energy from the sun to do your regeneration, and you can keep on using it for all the time. We're already at the stage that we have a small prototype where we can cool some food stuff just as a demonstration. But there are a lot of questions and developments we still need to answer about the capacities, about the size of the unit, etc. But we feel that we can make a very simple and very elegant cooling solution that actually works better if it's hotter outside as compared to all other air conditioning
Leon,
units.
we are wrapping up.
Yeah, so the wrap up indeed is we are looking for people that can maybe support us anything further about technology and development and design. And we are open for any partnerships in that space, going further from our already prototype. Small prototype, I have to say. Thank you very much.
Thank you, Leon. The next presentation is done by Martin Buchholz.
Yes, hello. Thank you for giving me the opportunity. Martin Buchholz from Watergy, company from Germany, from the Berlin-Brandenburg region. Can you give the slides? So I see still the last slide from the previous.
We see them,
Ah, yeah,
Martin.
okay.
I
So
see
sorry, I can switch to the slides that I can see. Okay, so we have a small research and technology-oriented company. We are one of the few institutions in Germany working on open absorption processes. That means we work on a liquid desiccant. These are hygroscopic salt solutions, and we work mainly on the absorber elements you see on the left, and working on new configurations of that. We focus on, yes, cooling, but it's also full climate control for buildings, so also has a heating component, and also have a focus on industrial drying. But here in the Pathfinder, we would like to focus now on a specific idea for the combined evaporative, sorptive cooling. Next slide, please. And that's the idea is that the evaporation provides the cool and the absorption provides the dehumidification. It also includes a kind of heat demand for the regeneration. So we are a bit similar to the previous application. And there is a lot of competition now in this field because there are big potentials for energy savings, let's say 40 to 80% less than a standard cooling technology. This is for sure. I know at least two US companies who work on innovative approaches with high investments, actually, and there is a competition for the best solutions, of course. Then we would like to integrate a PCM day-night heat storage. So that's also the idea to collect cool from the night and to collect heat from the day for the regeneration process. We also think about, so this could be a partnering company or institution which could support this part. We also think about heat sources like, for example, a solar hybrid collector could be a partnering device, but the heating source is not really crucial for the innovative process. So that could be also something we get from just buying some components. But of course, it would be nice when there is a very good innovative idea from that field to combine these solutions. That's also very interesting. And then finally, we look at water recovery. So if we work on evaporative cooling, we create a lot of water vapor, and water is also a limited factor. So technology to recover the water back by condensation, and also maybe the implementation of seawater.
Wrapping up.
Yes, seawater. And if there is any company working on the chemicals for seawater use in this field, would also be an interesting partner. Thank you.
Thank you very much, Martin. The next presentation will be done by Virginie and Metacool. Virginie? Virginie, can you hear us? Virginie? Yes, we can hear you, Virginie.
Do you hear me?
Yes, please go ahead.
Okay, I'm sorry. So I'm Virginie Ponsinet, and I come from a CNRS research institute in Bordeaux, in France. I speak for a multidisciplinary team of 7 researchers that identifies itself as Metacool. We are experts in advanced materials with innovative design, mostly based on polymers and inorganic particles, with tailored nano and microstructures to provide specific functions. beyond the state of the art. So we have been in particular aiming at controlling light-matter interaction in metamaterials using tailored optical resonances. We have also produced nanocomposite fibers for energy harvesting. Our team displays a wide panel of competencies ranging from electromagnetic simulations for materials or metamaterials design to different fabrication and shaping methodologies involving self-assembly and other soft matter processes. We have the expertise and equipment to produce particles of different natures, including complex ones, as well as different smart composite materials. We use an array of structural and functional techniques to assess the performances of the produced materials and to relate their structures with their properties. We wish to contribute, so we can move to the next slide. We wish to contribute in the proposal to clean and efficient cooling by applying our sets of skills and methodologies to the design of efficient materials for passive radiative coolings, in particular for buildings and vehicles. The phenomenon of radiative cooling is spontaneously occurring in materials with large infrared emissivity, and it can be made efficient in daytime if the design materials is also a good reflector of the solar radiation. We believe that these critical properties can be, which are the emissivity in the infrared and the reflectivity in the solar radiation, can be enhanced by an optimized and innovative design of the submicron structure of the material. On a non-scientific but important note, I would like to mention that our team has previously been the coordinator of a European FP7 project called MetaChem on self-assembled metamaterials, which has gathered 10 partners in 9 countries. And finally, we think in order to build a strong consortium, we need partners in complementary expertise, in particular in the field of thermal and building engineering, metrology, and technical textiles. Thank you.
Thanks a lot. And the next presentation will be done by Lorenzo Patelli. Lorenzo?
Yes, can you hear me?
Yes.
Okay, so good morning, everyone. I'm Lorenzo Patelli. You can go directly to the next slide. So I'm a researcher at the National Metrology Institute in Italy and at the European Laboratory for Nonlinear Spectroscopy. And my main research activities are focused on the fabrication and characterization of highly scattering materials, which we investigated experimentally using several experimental techniques, such as this kind of ultra-fast imaging, to study really how light and electromagnetic radiation propagates inside these materials, but also numerically, again, by developing high-performance software with which we are able to perform rigorous simulations for large 3D disordered systems. You can go to the next slide. So as we just heard from Virginie, and many of you know, really one recent and rapidly growing application of highly scattering materials is that of sub-ambient passive radiative cooling, because these materials are highly reflective in the whole solar range. So in the past few years, we have published a few papers on this topic together with collaborators from the Chinese Academy of Sciences and the Harbin Institute of Technology. And we are currently working on the characterization of the sub-ambient cooling performances of these materials under realistic conditions. Let me mention that our activities in this field are supported at the moment by a partnership of other European metrology and research institutes through the parametric project, which I am coordinating, and which aims at developing standard figures of merit and reproducible protocols to actually evaluate the potential cooling power of these newly proposed materials. This point on standardization was also mentioned by the program manager earlier. And we think it's also very, very important because there is really almost a reproducibility crisis at the moment in this largely and quickly expanding field. So as regards this EIC challenge, we intend to continue exploring porous materials which combine both high scattering efficiency with strong thermal insulation in order to protect the infrared emitters from both radiative and non-radiative heat gains, which at the moment we think represent one of the major bottlenecks or obstacles for both nighttime and daytime passive radiative cooling. So if we wish to develop new scattering materials with engineered disorder, or we want to propose highly stable samples that we could use for reference and calibration of this cooling effect, as well as standardized methods to evaluate their performance, you can reach out to us through the contacts that I've listed below. And with that, I'm done.
Thank you very much, Lorenzo. The next presentation will be done by Alessandro Pastore, Cambridge, sorry.
Okay. Hello, everybody, and thanks for this invitation. I'm Alessandro Pastore, co-founder and executive director of business development at Cambridge. Cambridge's mission is to create sustainable new cooling products. And for this reason, we put together a world-class team and also having a long series of history of collaboration with research centers worldwide. Originally, we have been a spin-off company from University of Cambridge. Our goal is to commercialize gas-free magnetic refrigeration technology, which is a platform technology with a wide range of applicability. We have reached by the end of 2022, so last year, a proof of principle of a magnetic cooling system, which is already today delivering enhanced appliance efficiency, avoids the use of critical materials, embodies low carbon production, is largely circularly recyclable at the end of life, and contains no refrigerant gases. The way our technology platform works is very simple. At the end, the cold generation allowed by the exploitation of properties of new alloys produce a cold circuit, which cool down our appliances, and a hot circuit that reject the heat or absorb the heat in case of an heat pump. And this way of working actually gives an unprecedented level of appliance design flexibility, enhances step change in appliance energy efficiency, up to divided by 2 by 4 the overall energy consumed over a year. Next slide, please. How we reach this and what is our platform technology and why we are here today. Precisely for what Anne-Marie said, we are here to provide a purpose for your research to make this technology manufacturable and brought to the market. And for this reason, we are seeking partners to develop advanced magnetic material processing, innovative automated assembly methods, novel heat exchanger. The way the heat is absorbed no longer needs any metals, but can be done by plastic heat exchanger. We are the only alternative to the vapor compressor. And as one of the OEM who just visited us a couple of months ago said, that the head of R&D is a paradigm shift. We offer this technology platform for new ideas, and we are more than willing to receive your ideas in the manufacturing enhancement of our technology. Thank you. You can reach us, either via the website or directly via LinkedIn, Alessandro Pastore. Thank you.
Thanks a lot, Alessandro. Next presentation will be done by Albert Castel. Albert, the floor is yours.
Thank you. Hello, my name is Albert Castel. I'm a professor at the University of Lleida in Catalonia in Spain, and I also speak for a research group of different professors. We have mainly backgrounds in industrial engineering, chemical engineering, and architecture. We have deep and long experience in working in the International Energy Agency, in tasks, annexes, in European projects, for example, in topics such as thermal energy storage, mainly with phase change materials, and combined renewable heating and cooling. And currently we are active in several national projects on the topic of what we call radiative collector and emitter, which it's a concept or a new technology combining two technologies, radiative cooling and solar thermal collection in a single, let's say, device or concept. Okay. We had first concept and technology developed to TRL5, but this was using nighttime radiative cooling, which was less challenging. And now in this proposal, we want to move to a much more challenging concept and that has more potential of breakthrough, which is using daytime radiative cooling combined with solar thermal collection to produce both hot water and cold water. So in this point, we are looking forward to find interested partners for this proposal. So if we go to the next slide, please. our proposal, it's mainly focused on using these two technologies, radiative cooling, but not only passive daytime radiative cooling, but also to actively produce cold water that can be used for different applications. And in the same device or technology, also use solar thermal collection to produce hot water. So during daytime, we will produce both cold water and hot water, and during nighttime, we will produce cold water. We have more than 7 years of experience working with these technologies and radiative cooling. We are one of the few research groups in the world working with this combination and in let's say in the engineering part, not only in material developing. We have projects and papers on that you can find online if you want. And well, the key research topics on this core concept of the project that we propose, it's the materials for an adaptive cover, because if we want to allow both physical phenomena, radiative cooling and solar collection, the cover must adapt to its properties to each process. Also materials for daytime radiative cooling. I have already seen some potential matches in previous speeches in this session, because we don't have, or we are looking for expertise in material developing. And what we offer and what we have, it's mainly a lot of expertise in thermal engineering, in heat transfer, fluid dynamics, and design or even testing materials, but not just the material, but looking at the application also. We have also worked in mapping the potential of the radiative cooling in Europe. And with this, we have demonstrated that the technology can be very helpful to cover demands of cooling. We looked at demands on buildings, application on buildings, and it can be useful for both the current climate situation, and we also analyzed it for future climate change scenarios, and we see that the potential of radiative cooling is robust and it's a resilient technology for the future. So we are looking for potential partners, as I said, mainly on materials probably, that want to join us in a project. Thank you.
Thanks a lot, Albert. And next presentation will be done by Gianmarco Rianese. So Gianmarco.
Yes. Can you hear me?
Yes.
Okay, so I'm Gianmarco Rianese. I'm a professor at the Université Catholique de Louvain in Belgium, and also one of the co-founders of Magenics, which is a spin-off of the university. So we work in high throughput screening and machine learning to design new materials. So the main idea is that experimentally, most often the design of materials proceed by trial and error. And so if you see the example here of Edison, when he tried to find the material for the filament of the bulb lamp, he tested many different materials, most of which, after trying to synthesize them and characterizing them, they ended up in the dumpster. So you see a lot of red at the bottom of the different columns there. And once in a while, you have some material that meet the requirement that you have. So basically, you need to test a lot of materials, and the ones that you test are sometimes, they're based on your intuition, and the success that you meet often occurs by serendipity. Can you move to the next slide, please? So basically what we offer is services based on 3 pillars. So data, computer simulations, and artificial intelligence. So the simulation, that's where we come from. We have simulation at different scales, so both including electrons and atomic level, but we can go to higher scales. Based on that, and there's been many of such opportunities appearing in the last years of developing a database where you can find materials. And we are developing one of the things which is called Optimate, which is an API to interrogate the different databases. And once you have these data, you can start using artificial intelligence to basically accelerate the whole process of materials development. And so we are mastering different tools there. And at the core of that, we are implementing workflows to accelerate the whole point where you want to compute new materials, consolidate the data, and then use the materials, artificial intelligence, to find the new materials. And that's basically what we are offering. And this can be applied, of course, to finding new materials for cooling. Thank you very much.
Thank you very much, Gianmarco. So next presentation will be done by Ioannis Papakonstantinou. Ioannis, please go ahead.
Yes, hi everyone. So I guess there is no animation because my slides have some animation, never mind. So the colleagues before me, my name is Ioannis Papakonstantinou, I'm the head of the Photonic Innovations Lab in the Department of Electronic and Electrical Engineering at University College London. And I'm going to talk about radiative cooling, a subject that was also covered by some of the speakers before. But the idea here is you have a surface that combines high solar reflectance and high emissivity, particularly in what is known as the mid-infrared transparency window between 8 and 13 microns, and the combination of the two can achieve net cooling. And as a matter of fact, we have a project funded by an EIC proof of concept called Polycool, whereby we have developed some solutions that we can spray or deep coat or even convert into polymer films. And we have seen radiative cooling to about 4 to 5 degrees below the ambient. Can we move to the next slide, please? Okay, building onto these two concepts. So on the previous concept, I'm going to propose two concepts, actually. The way I see radiative cooling moving forward is in the following. First of all, in climates like temperate or continental, where we have in Europe, static cooling is certainly not the solution, because what tends to happen is what's known as overcooling. So you have the air condition operating during the winter, and that imposes a penalty for heating. So what we are proposing here is a self-adaptive radiative cooling solution. And as a matter of fact, we have some prototypes. On the bottom side, what you see is a polymer film where we have developed our own thermochromic-based nano antennas, as we call them. And we can modulate the emissivity from about 0.9 in the summer to less than 0.4 in the winter. So you can have a system whose cooling gains can be adapted to the ambient temperature. Now, what you see on the right hand is the next big challenge in radiative cooling, in that the question we're trying to address here is, can we achieve actually freezing temperatures? Because most of 90% or most of the systems, most of the radiative cooling systems in the literature can only go to about 3 to 4 degrees below ambient. This is because they're exposed to natural convective effects. But if you reduce natural convective effects and the U value of the system reduces to less than 1 watt per meter square Kelvin, then you can actually go to refrigeration temperatures, even minus 30, minus 40 degrees. So in many ways, radiative cooling is at its infancy. So we have ways of doing that by combining vacuum insulation technologies, like, for example, the ones that you find in vacuum insulation glazing or vacuum insulation panels. And we'd like to explore more in this Pathfinder the possibility of achieving sub-freezing temperatures. What we would be looking for in terms of partners is partners with experience in vacuum insulation technologies, partners with experience in heat transfer, partners with experience in scalability. How can we scale up these concepts? And of course, industrial partners that can look into applications such as, for example, cooling of data centers, cooling of refrigeration trucks, and so on. So thank you very much.
Thanks a lot, Ioannis. Next presentation will be done by Lovisa Hjortberg. So Lovisa.
Thank you. Thank you for inviting me here. Really interesting presentation so far. My name is Lovisa. I'm leading the commercialization of Sutrusion, which is a completely new and patented 3D manufacturing technology. So in short, what we are doing is that we're solving the problem with high cost of production associated with producing complex 3D structures needed for lightweight optimizations and cooling topologies. Sutrusion tool, as you can see on the left, simply upgrades one of the most commonly used manufacturing technologies in the world, namely extrusion. And we can thereby produce 3D components and complex cooling topologies in anything from aluminum to polymers and technical ceramics in one single cost-efficient step. So to showcase the ability and versatility of Sutrusion, we have developed a completely new tab-cooled aluminum battery pack solution. The battery pack consists of aluminum profiles, as you can see in the picture there. The profile combines fixation of cells, lightweight optimization structures, cooling channels to enable efficient tab cooling. So this tab cooling battery pack, as can be seen in the third image, gives the possibility to cool cells top and bottom, means you can charge and discharge the cells very fast without having high temperature at the core of the cell. We've managed to achieve a 6-minute charging, both in simulation and live test, from a 20 to 80% state of charge, with a nice and even temperature, no overheating in the cells, which means a longer life of the battery cell, estimated increased lifetime of about 2 to 3 times, which we are very happy for. So the concept also shows the opportunity to save up to 20 to 50% weight of the battery pack and reduce components with up to 50%, which means a massive reduced environmental impact, of course. But I want to stress foremost maybe that substitution is a technology to make these types of designs a viable business case by cutting costs massively. We've seen approximate up to 95% cost cut compared to other manufacturing alternatives. So these battery packs can be easily integrated into vehicle structures, remolded when there's a need for scalability, fits any cell model, cylindric, prismatic, pouches, etc. We can jump to the next slide. So basically, we offer the ability to mass produce highly efficient tab-cooled battery packs and in general complex 3D cooling structures. The ability has granted us the funding from European Innovation Council of 6 million euros total. And we are now accelerating this technology towards battery pack manufacturing with OEMs and experts. And we are now entering a collaboration phase where we will set true the first of these profile in our tech center in Sweden. We will iterate together with OEMs and experts who can set the requirements and goals for the project, make this technology and battery designs really automotive ready. So basically in the near term, there's an opportunity, of course, to be part of this project. The benefit would be to have a front row seat of a completely new manufacturing technology, get a head start in applying this type of manufacturing in battery pack designs, and improve charging and battery lifetimes. But we are also looking for partners in other thermal management and cooling projects. For example, we are now working in a fuel cell project where we will produce the world's first bipolar fuel cell plates with substitution by the end of 2023. So we are very open for any dialogues with experts in cooling and fuel cell plate design, etc. for this type of project. Thank you very much. That's all for me.
Thank you very much, Lovisa. The next presentation will be done by Paul Motzky. Professor Motzky, your turn.
Hello. Yeah, thank you very much for having me. I'm professor at Saarland University, and the partners for our proposed project are 2 more universities, one in Italy, in Naples, and in Slovenia, in Ljubljana. And we have an SME, the company Exogen in Ireland. Our idea is to use decentralized elastocaloric climatization systems, especially for the building sector. So this would be the use case we're envisioning and we want to attack. And all of the 4 partners have extensive experience in the field of elastocalorics, following different research approaches regarding systems, materials, and system design and energy transfer strategies. Why is it important? We saw it also in the talks before. The building sector, or in general, the cooling is going to have a huge demand increasing over the next couple of years. And this is something we need to attack. Elastocalorics offers a very high potential of attacking this problem because of the huge energy efficiency that can be reached, hopefully, and the zero global warming potential that goes with it, because we don't need cooling agents. So the project goal will be to develop, especially for this application, driven by the idea of this application, and demonstrator or a demonstrator platform for validation of this idea. And if you go to the next slide, I can shortly give an idea why we think this is a good approach. Material measurements, first material measurements, have shown the huge potential as far as COPs that you can reach compared to the vapor compression systems nowadays. I mentioned that we don't need volatile agents necessarily, and this is the reason why the technology of elasticalorics has already been declared as the most promising alternative to vapor compression. So it can be used as heat pumps or cooling devices. So it's overall climatization of buildings. And what we're really looking for is probably in our consortium a partner that is already in the field of decentralized building climatization in comparison to the mostly centralized existing building infrastructures. So we can attack the idea of retrofit and a quick transformation of the building sector regarding decarbonization and energy efficiency in the future. Thank you.
Thank you very much. So the last but not least is the presentation of Yair Sued, and he will present Sphere.
Thank you very much. Hello, everyone. My name is Yair Sued, and I am the co-founder and the CEO of Sphere Technologies. Sphere is a startup company that's located in Israel, and I want to present you our disruptive cooling technology. By figuring that the main component that influences the energy consumption in cooling cycle is the condenser, we have developed an innovative one that rejects the heat in unique and patented method. The main advantage of that system is the energy efficiency. In this system, the electricity consumption is at least 50% lower. Another important issue is the system size. The footprint of our system is 4 times smaller, so the consumer can cool more in smaller area. Those significant savings in operation costs are not the whole story. Look how we reduce emissions. Every system in size of 10-ton refrigerant saves 25 ton CO2 per year. So beside the savings in operation costs, you will increase your impact. Next slide, please. Since we recognize that the need and the pain in the industry are the greatest, we are starting with a modular 10-ton cooling system. We signed and started a pilot with Bazan refinery on an industrial process that they managed to cool with limited efficiency, and now it is under construction. We are going to reduce the electricity expenses in that process by 40%, and in addition, significantly increase the cooling output since the process is closed for the summer months. But industry is just the beginning. We are able to implement our solution in every cooling system in any size. The process of expanding after this pilot with Bazan will be through the execution of 3 more pilots and then expanding to the EU using a strategic partner. So if you want clean and efficient cooling at your data center, building, or for your food, I invite you to contact us and see our solution in action. Thank you very much.
Thanks a lot, everyone. It was great to have your presentations. Anne-Marie and Marco, the floor is yours.
Well, I don't have so much to add, other than I'm very happy to see these very interesting ideas. I knew already some of them. Others are well aligned with the inspiration and the topic of the clean cooling. So I just have to wish you all the best. Good luck.
Marco, we can still answer some remaining questions.
Yes, but I think that we should finish at 11. No, that is what
No, we still have a bit of time. So for the people who want to continue listening, we can answer the remaining questions.
Okay.
Because some of them were really on the topic, so I think it's good if we answer them.
Yeah, should proposal include work product for life cycle analysis of proposed technology product? This is not mandatory, but is highly encouraged because there is also a mention on circularity and reuse or recycle. We did not put this as a mandatory as for other challenges, but is strongly encouraged to, and for sure the evaluators will check if the materials and the supply chain that you are proposing is circular and sustainable. Can you please explain the following? The proposed solution should aim to achieve single stage temperature gradient higher than 5 degrees at a competitive COP. Exactly what this means. If your result is to have a temperature gradient, a cooling effect of less than 5 Celsius, This is not what we are looking for. We want to have a single stage temperature gradients of minimum 5 degrees. Competitive COP, the ambition should be to have a solution that can have a COP, if it is successful, not of 0.1 or 0.5, but competitive with the alternative option for that application. If you are targeting application where vapor compression are not a solution, and maybe you don't have solution with COP or 3, 4, 7, of course, this is clear, and you can target a COP that could be even 1, but competitive for that specific target application. About portfolio consideration, will similar contrasted complementary materials be considered for selection? Well, we address diversity and complementarity. So we want to address both different kind of solutions, technologies, and find commonalities among these solutions. I cannot tell you if the use of the same material will be an advantage, or we want to have for the same application 2 different materials, because if we don't see the proposal, it's difficult to carry out this consideration. We just report the broader portfolio consideration, but I cannot say if we will look for similar or contrasted complementary materials. If an excellent proposal is not easy to be connected to other projects in the portfolio step, can it still be discarded in that stage? Well, the ambition is to have an excellent portfolio composed by excellent proposals. Of course, a proposal is the very top, the best one, is rather difficult that we will exclude it from portfolio. It is theoretically possible if it does not fit with the ambition of portfolio, even if it has the highest score, could be not retained, but this should be properly justified with portfolio consideration. Usually, we start to compose a portfolio from the excellent, the highest score ones, but this is not a general rule. It depends on what we have.
So, Antonio and Marco, I just would like to add to that, because that sounds. So we always start from the highest ranked proposals, and then we look to a portfolio of proposals that really make sense and where the projects that are in the portfolio have an added value. So if, for instance, there is a very good proposal, but there's another one that is better, and it is almost the same proposal, you know, it has really similar characteristics, then it's very likely that the proposal, the second one, which is lower scoring, but which is, let's say, a duplicate of the first one, will not be selected. Or if there's really no connection with other proposals of one proposal, it can also be discarded, because there are other proposals which are almost as good that fit better the portfolio consideration. So there can be a change. We're not following strictly the score obtained, but we always start from the highest proposals, and we want to include as much as possible the best proposals.
Absolutely, yes. This I don't understand the meaning. Can proposal be amended if there is learning between application and grant?
So you cannot amend a proposal. So your proposal, once it is submitted, that's what it is. That is what will be evaluated. If you are selected and you have learned something, you can include the new learnings when you start the grant. Then there is the possibility to update. Also, if you do a project, the project can also be amended, but you cannot amend a proposal.
Yeah. Electricity generation from LNG and liquefied hydrogen regasification within scope, not the electricity generation from hydrogen. If you recover if you produce in a better way cooling for cryogenic, or you recover that energy, well, that can be in scope, but the electricity generation, if you mean electricity generation from the energy carrier, of course, it is not in scope. The possibility to, well, the focus is cooling, generate cooling and manage cooling, not produce electricity. If you produce electricity for cooling, that could make sense, but we want to see the clear connection and the novelty of this cooling. The focus is to produce cooling to liquefy the energy carrier. Can a defense company be part of the consortium, Anne-Marie?
Yes, it can be part of the consortium, but we are only funding civil research, so it has to be for civil applications.
Yes.
But any company is eligible to participate.
If the project is included in portfolio, the derived activities for collaboration with it other project will be covered as an extra budget. No, it should be included in that work program on portfolio activities with minimum 10 man months that you should consider when submitting the proposal. So you should allocate a budget for portfolio activities. Then if we see that there are other activities not forecast at the beginning, but different from what is signed in the grant agreement, and the grant agreement includes portfolio activities, then there could be other tools for extra budget. But you should include now budget for portfolio activities that will be included in the grant agreement. For question related to Switzerland,
This has already answered, so
yes,
it's okay.
yeah.
You can we can skip it.
Online tool for partner search.
Yeah, I have also answered that in the already in the doodle, or what's it called again, in the Slido. So there are in the funding and tender portal, you can find something. You can also look with your national contact point. So there are tools available for that.
Yeah, still about Pathfinder transition relation. Imagine an older project, a low TRL failed and needs reorienteering. Is this call feasible for that purpose? Well, it depends on which kind of reorienting. If you want to explore a new advancement, a clearly new solution that clearly advance on state of art, that's Pathfinder. If you already got money with a FET or transition, and you are not successful, it failed. It depends why. If you need to still undertake fundamental science, fundamental research level, low TRL, maybe you can apply for Pathfinder. If you failed because of not proper scaling up, maybe you can submit for transition.
And of course, the topic should be about clean and efficient cooling. So it should really be in scope with the call, with this challenge.
Is a more efficient cooling technology for machining, metal cutting in the scope? Well, it's not actually the main ambitious. If the target is to I don't know, such sort of cryogenic vitrification solution for laser drilling or metal cutting. Yes, there could be a link, but the focus should be really on the advancement in how you produce this cooling and you manage this cooling also for, yes, some mechanical processing, cutting devices. It is included because we added also industrial sector, application for industrial sector. The main target was health, pharmaceuticals, data center, food, chemical sector, and large cooling demand. But if you are convincing, demonstrating that the energy consumption for that cooling process is consistent, this can be can have an impact, then it could be yes, interesting. What is the minimum number of participants in a consortium?
Yeah, so
one.
Even a single participant can submit a proposal. Of course, this single participant, then I think an SME, then needs to be able to carry out such an extensive project and do all the groundbreaking research, but it is possible. I advise you to look in the work program. There it's explained exactly what it is, and also to watch the general info day. So we have also had a general info day in December, which explains all these details. Today, we wanted to focus more on the specific issues of clean and efficient cooling.
Yeah. Can one lab be a partner in your event proposal? Yes, there is always the consideration about focus. Do not disperse your energy in several proposals, but focus on one very good submission. This is as an advice. This is up to Sphere, and you can have interaction with them. This is already, we replied already. If the project is included in portfolio, there is no extra budget for portfolio activities. Should be included in the grant agreement.
Okay, so now we are at the end of the info day. Thank you very much, Marco, for the presentation. Thank you very much, 11 presenters who have explained their technology and formed a seat for matchmaking for proposals. Thank you very much, Maria Laura and Jenny, for all the assistance with the info day. So as said, this will be recorded, so you can look later at your convenience again to this session. And if you have further questions, please contact your national contact point. They will answer all your questions. And if there is something that they don't know, they will contact Marco for the specific answer to that question. But Marco is not in a position to answer your questions directly, because that would mean he gives some privileged information to one beneficiary and not to others, and that would be unfair treatment. So he cannot answer directly your questions. But the national contact points, they are ready to answer all your questions. So with this, we hope for many very good proposals, and we wish you good luck. And thank you for attention in this topic.
Thank you very much, Maria, all of you
Thank you.
for attending.
Thank you.
Bye-bye.
Thank you. Bye.